Problem number 3, super similar to problem number 2, but anyway, we have this rock that's thrown vertically upward from the surface of the moon, goes up, then comes back down, and you can see that the position of this object is given to you, the position function. And for part A, though, we're supposed to find the velocity, and the velocity, let me do this, velocity in terms of t as a function of t is just the derivative of the position. So the rate of change of the position, which would be 24 minus 1.6 times t. And then the acceleration, it tells us to find acceleration in terms of t, and that's just the derivative of the velocity, or the rate of change of the velocity. So if we're writing this in terms of using the units, if we look back here, it's meters per second. So meters per second for the velocity, and then meters per second, or meters per second squared would be the acceleration, negative 1.6. So that's part A. Part B, how high did the rock go? Well, the same kind of thing. Well, we know that at the very top, at the maximum height, I should say, is that's where the velocity is equal to 0. And that's the only thing we really know. We don't know how long it takes for the velocity to equal 0, and that's how we find this for part B. We want to set the velocity equal to 0, okay, because that will tell us at what time it reaches its maximum height. So the velocity is equal to 0 when the velocity function 24 minus 1.6 t is equal to 0. So I'll let you solve that one on your own as far as doing the steps, but we see that 1.6 t equaling 24 at t equals 15 seconds. So at the 15-second mark, so we'll keep labeling our diagram here, that's when t equals 15, and for part B, it's asking us, well, how high did it go? Well, the height depends on t. The t depends on the velocity being 0, and so now that we have that t equaling 15, we can just replace t with 15 in the position equation, because the position at time 15 will tell us, well, how high is it? Well, that's 24 times 15. Okay, and then minus, I'm looking at my screen in front of me here, minus 0.8 times 15 squared, minus 0.8 times 15 squared, and that number is 180 meters. 180 and meters. That's actually part C. Okay. How high did the rock go? And how long did it take the rock to reach its highest point? That was the answer for part B. And part C, how high did the rock go? And what do we have next? Part D is, when did the rock reach half its maximum height? So we want to know t equals whatever. We don't know when the position, it says half of its maximum height. So when the position is equal to 90. Okay. Well, we have an equation, S, function, S equals 24t. So to solve this, we set the S of t, 24t minus 0.8t squared, equal to 90. And if you, I guess you're going to have to use your graphing calculator. Use the quadratic formula program, and when you use that program, you get that t has a value of 4.393 seconds, and also 25.607 seconds. And so this equation is solved by these two solutions. So when t equals these two values, the rock has reached half of its maximum height. And so we can continue to label our diagram. On the way up, And let's see here. And arrows on the way up, arrows on the way down. At the 90, so this is 90 meters, and that's when t has a value of I'm just going to go 4.4 seconds, and also on the way back down is 25.6 seconds, and seconds there as well. Okay, and then so that's part D. Are there more parts to this one? No. So part E, how long was the rock aloft? All right. Well, if it says that the rock was thrown vertically upward from the surface of the moon, and the surface, from the surface to the maximum height took 15 seconds, so it's going to take 15 seconds to come back down, so 30 seconds total. But to actually solve that using, because you'll need to know how to solve it using the formula, because sometimes the rock or whatever is thrown upward isn't thrown up from the surface, it's thrown up from a height of whatever, 3, 4, 5, 6 feet usually, something like that. But nevertheless, what we want is the time in which the position of the particle, in this case the rock, is equal to 0. Because looking at the graph of this whole situation over here, right down here on the bottom, okay, this is where the position, the height, remember, S in this case represents the height of this rock at a certain time. So the position or the height being equal to 0 would indicate that that rock is on the surface of the moon. Otherwise, up here at 90, that's when the position is equal to 90. Okay, and S of 4.4 is 90. S of 25.6 is also 90. So being able to interpret what is going on here is very helpful. Be able to solve any of these kinds of questions. And so S of t equaling 0 means that 24t minus 0.8 t squared is equal to 0. And that's when t equals 0. And also, I'll let you solve this, t equals 30 seconds, as I said. And so 30 seconds is obviously the number, hopefully it's obvious, the number that represents the amount of time that the rock was in the air. Okay, I'm going to sign off here, and then pages 90 and 91, or 91 and 92, I will do in the next video.